Hi, welcome to lesson 3, the Earth's structure. Um, I think the next section gets far more interesting. When you look at the Earth's structure, I think it's incredible. It's mesmerizing in terms of it's still difficult to really kind of comprehend what's going on beneath us, and let alone that it's responsible for so many incredible events like volcanic eruptions and earthquakes, which are both life bringers and life takers, and just the sheer timescale of everything. And you can see in the animation above some references to some stuff that you would have learned when you were in Key Stage 3 primary school, years 10 and 11. So anyway, so if I move on to the next slide. So on this slide here, again, I put the spec link in here. So remember, the first two lessons were really concerned with making sure that you understood the concepts of hazards, some of the models, management models, and so forth. And they're obviously very, very important. But this is the stuff that gets kind of very visual. Okay. What I'm going to attempt to explore in today's lesson really is just the Earth's structure. So in many ways, very much the very first sentence. Sorry, just a pop-up device appeared on my screen as I was talking. So that very short sentence, so if I just bring up the laser pointer, so just this bit here, there's enough there to be getting on with anyway. Subsequently, this lays the foundations going into this theory here called plate tectonics theory. In the grand scheme of things, it's a relatively new theory, so really gained the general consensus really in the early 1970s. So obviously there were bits and bobs that were put together. So definitely explore that in subsequent lessons from that to, why we get mountains, why we get volcanoes, ocean trenches, etc. And there definitely are a bunch of landforms, landscapes that you need to learn for this, and they do come up, right? And if you look at this section here, that elaborates on it more in depth. So all these things here you see, 4 markers, 9 markers, 20 markers, they all relate to. So if you're going to be at A-star level, you cannot afford to have some gaps in your knowledge here. But let's start with this bit here, the basics. Now, before we do get into that basics, I've put up not my favorite place, but certainly up there. And think about where this might be. And the second question is the more interesting question. So this is, drum roll, this is the Grand Canyons, right? I've been lucky enough to be here a couple of times, school trips and my own holiday trips. Now, at its deepest, from the top of the canyon down to the base, where the Colorado River flows, it's 1.6 kilometers depth, 1 mile old school, funny. And its widest, this is certainly not the widest bit, from here to here, well over 40 kilometers wide. Why I put this picture in here, because it does relate to the topic that we're doing. This is part of the Earth's structure, it's part of the crust. And this is a very thin slither of it. When you look here, though, from the apex or the top of the canyon, working your way down here, you can see all these layers. And if you've done your coastal unit, you'll recognize these are horizontal layers, and the lines in between are bedding planes. This is sandstone, and it has been said there's 2 billion years worth of history here, right? I've been lucky enough to be on a river raft going through the Colorado River, which is incredibly cold. Um, and anyway, so why I think this is interesting, and it definitely links in with this unit. So hundreds of millions of years ago, this point would have been on the seabed, 1.6 kilometers below the sea. Now it's 1.6 kilometers above the sea. So that's a 3.2 kilometer or 2 mile shift down here to up here. That's to do with the Earth's crust, and the topic, that plate tectonics topic, is there's a shift. It's physically moving down here, up here. I find that just crazy to think about. And you learn about that. And then the other side of it is, how do we get this canyon? This river has carved its way down, again, over millions of years down to the base, not as a straight line, it's sidewinded. Then you've had like mass movement events, and you can see all this like, rubble sliding in. So it's 2 billion years worth of history, plate tectonics, river erosion, and that's what makes this subject so fascinating. But let's get more back down to basics. So the key point of this lesson, lesson 3, is to make sure you're clear about the layers of the Earth, some of the details behind those layers, but then to take it into moving on, certainly from where you would have learned about Key Stage 3, possibly Key Stage 4. There's always a bit of an overlap there with some teachers, and certainly making the distinctions that you need for Key Stage 5, your A-level geography. So you'll get the layers, the key characteristics of the layers, things like depth, they're kind of composed of, and so forth. The processes in this lesson less so. That will be kind of examined more in lesson 4, lesson 5 type sort of information. So at Key Stage 3, primary school, secondary school, etc., this concept here of the Earth structure, where we have a crust, we have a mantle, we have the outer core and the inner core. That's what you're taught. It looks very simplistic. This structure still maintains, right? So you still hold this, but there are much more nuances. There are sub-levels, sub-layers to this, and there's certainly about 3 slides or so time. You understand that this crust acts on its own as a layer, but there is a combination layer and then a layer below that. So the mantle itself is a little bit more complex than what you've been taught, certainly low down the years. So we'll explore that. Still sticking to our basics here, and just a little bit more description. So that crust is relatively thin. The mantle underneath it, that molten rock, that will be repeated a few times. That's actually the biggest layer, the thickest layer, nearly 3,000 kilometers thick. And then you have the core, which is divided into inner and outer core. And they say the outer core spins fluid-like. And then you have the inner core, where it's the hottest. Different sorts of materials, elements that make that up, but incredibly hot, but so compressed by pressure that it behaves as a solid. Okay. Now, this slide here exists purely so that you can practice, labeling it, describing it, and so forth. And on the next slide, I still keep to that very 4 basic layer plan. So if we look at this, keeping it simple to start with, and then scaffold and build it up later, the crust is said to be between 4 and 70 kilometers thick. Different textbooks will have with different versions of that, and averages and so forth. So under the oceans, where the crust is, usually that's the thinnest, and it can be roughly 4 kilometers thick before you get to the mantle. And where the mountains are, the continents, it can be 70 kilometers thick. And there are averages. And start that process now. There are 2 main types of crust: oceanic and continental crust. More on that later on. Then you can see this generic term here for the next layer, the biggest layer. There's that distance, the thickness of that. And, all sorts of different elements, metals in there, but iron and magnesium are the key ones they mention. And just under the crust, you're probably talking about 1,500 degrees. And then as you descend further down, about 3,000 degrees. It's hard to imagine that. So when you're talking about 1,500 degrees, it's 15 times the temperature which water boils. Okay. And where you're sitting at the moment, which is probably in England, but maybe other parts of the world, you think in a distance that, I live in Chelmsford, 50 odd kilometers away. So in a distance much less than that, but downwards, there is a fiery inferno below me. And as I look out into the night sky and the calmness around me, it's just such a difficult thing to kind of absorb. There's that bit about the outer core. As I said, it's more fluid-like and it spins. Very important that it does that. And then the inner core, that you can see the temperature ratchets up. Some people say the inner core, its temperatures are equal to the temperatures on the surface of the sun. I've also heard that the outer and inner core collectively, if you took them as a ball sphere, about the size of Mars. Now, this picture here is quite important to get in the next slide. If you haven't learned this, you certainly need to make the distinction. Some very odd colours here, and this diagram certainly not to scale. So the crust mantle, outer core, inner core still holds true. You need to know there are some combination layers, some sub layers that you need to be aware of. Let's start with this first one here. So when I move the mouse here, I've got lithosphere, litho meaning rock. And you can see there and there, that yellow mustard color, there's your crust. Okay, that holds true. But where the variance is here, the very top part of the mantle, now remember the mantle is 2,900 kilometers thick. We're saying there's the very top layer, which is a little bit harder, a little bit cooler, a bit more plastic. It does deform and thicken and thin, but it's attached to the crust, like some sort of fascia attached to it. So we have this combination layer, the lithosphere. That's important to remember because some of the diagrams you look at, they relate to the lithosphere. And lower down the years, you may have not seen those before, and you go, what is that? Okay. So this grey bit, although it's part of the lithosphere, it's connected to the crust, so it's got that combination layer. Remember, this grey bit is the very top slither, the start point, but the very top part of the mantle. And if you look here, remember the mantle goes all the way down here. Now, another layer that's important is the asthenosphere. It's very like, I think, Greek word for weak rock. And this is not fluid, but they think this is much more molten, and this can extend down several hundred kilometers where convection cells flow, and the theory is it helps to move the crust above it. Okay. Now, layers underneath this, so I go to this orange layer and this yellow layer. Some people say this is the mesosphere, and I do have some notes on here, but I think it's unlikely you'll be asked to talk about the lower mantle here. Okay, so obviously you have this idea that what the mantle is, the size of it and so forth, and it's generically, it's magma, molten rock. Magma is that name of the generic name for the molten rock under the crust. Okay, but the section of the mantle that you really need to get to grips with is the part of the lithosphere, that combo layer, and this asthenosphere section here where it flows more. Again, not liquid, more like treacle. Not treacle you want to eat. And then realizing as we descend, it gets hotter, and this really is the engine of the Earth. So the sorts of heat that are given out by the core is one of you know when if you have a fire and it goes out, it still gives off heat, right? So you've still got that sort of decay, and then you've also got the radioactive element, radioactive decay, where it emits lots of heat. And it's amazing to think that goes on for billions of years, but I suppose some point in the future it will go inert and cold, probably long after humanity's gone extinct or evolved. So just some things here to examine with the lithosphere. So Greek word for rock. You're not going to be mentioning that in an exam, but getting this idea between 70 and 250 kilometers thick. Remember, that's the crust plus the top part of the mantle. Okay. Now, and again, you'll see on some of the, I've put some video links on the end of this here, depending on how much you want to go into detail. So oceanic, you're saying it's comprised of mostly silica and magnesium, and continental crust, silica and aluminium. And there are some other classifications of that you can look at. The continental crust on average is around about 35 kilometers thick. Remember, that's not including the upper part of the mantle, so that's really zoning on that particular bit. And that's an average. Remember, you've got mountains and you've got low-lying areas. And again, we've got our averages here. And a few sort of, a few extra details as such. Basalt, 6 to 10 kilometers thick. And if you don't know already, which many of you will know, is that although the oceanic crust is thinner, it is denser than the continental crust. That is really important. That just getting that distinction right. Oceanic denser than continental crust. That plays a key role in the processes and many of the landscapes, landforms that are formed by tectonic activity. Well, so the Earth's crust. There are lots of different types of rock, but three broad categories. We don't want to get like too bogged down in this. Certainly, if you're doing coasts, you make a reference to this water and carbon cycle, physical geography, definitely. The igneous rock's really coming from within the mantle. So magma comes up through the crust. It might solidify, forming new crust, and we call it intrusive. If it gets onto the land, like erupts onto the surface, whether that be on the ocean floor or onto the mainland on the continents, we then call it lava, right? So extrusive. That's just an example of, would be an example of extrusive landforms. Now, this unit is not really getting into the geology heavily, but that type of rock, igneous rock, is a classic example of that. It's not the only one. And that's really tough, resistant rock. Okay. Sedimentary rock. This is material that's maybe been eroded, ground down over many, many thousands, hundreds of thousands, millions of years. Rivers, for example, will deposit sediment in the sea, especially where the sea is calm and the sediment goes in the sea, drops to the bottom, builds up, layer upon layer, compresses, turns into hard rock. Going back to that slide at the beginning of the Grand Canyons, that used to be under the sea. That sandstone would have been deposits of sand dropping on the seabed, getting compressed and turning into rock, like sandstone. Okay, there are other types, and this is not that lesson for that. Metamorphic rock is rock that's been altered by pressure and heat over time. Diamonds from carbon, from coal, for instance. And the geology that I'm mentioning here is very, very rudimentary, but just to give you that illustration, that clarification on them. And this unit, we're not going to get too bogged down with that. So let's focus a little bit on the top layer here, some details. Okay. So if we take the crust, and we are going into the lithosphere as well. Remember, lithosphere, it's the crust and the top part of the mantle. Top part of the mantle, which is not molten, but is more plastic-like. That means it does, like if you pressure, it does change shape, does get thicker, denser, does get thinner. So let's have a closer look at that. Let your eyes adjust to this. So if we look at this picture here, there's our continental crust. Remember, I said on average 35 kilometers thick, where the mountains are much thicker. Although it is thicker, it's less dense. And the ocean crust over here, 4 to 10 kilometers thick, is denser. And as a result, and again, this will be repeated numerous times, because it's denser, where the two do move together, this will go underneath that crust. Now, remember, there's that word lithosphere. That's the top part of the mantle. Firmer, does change shape. Now, although it says plastic, I want you to think this flows more. Once you start going below this, in terms of A-level geography, you might have some awareness of it, but you're not going to go into depth here. And I think this in itself, there's a tremendous bit of complexity here going on. Okay. And if I go on to the slide, let's keep it simple. Continental versus oceanic. If you really get involved in this kind of science, this kind of geography, you can go into all the sub layers and so forth. It's quite fascinating when you go into it. Personally, I think at this point, keep it simple. You will find that none of the answers require you to go into that level of detail, and there could be an element of you getting confused. But if you're passionate about the subject, which many of you are, just come on and look at this. So, key differences between the two types of crust or lithosphere. Mentioned that thickness. There's the continental. There's the oceanic. I definitely think that's probably worth learning. Age, isn't that fascinating? 1.5 billion years old, very stable, doesn't break down very easily. Oceanic crust is formed and destroyed relatively quickly, 200 million years. Quickly. So this geologically quick. From our point of view, that's an eternity. Can't even really conceive that sort of timescale properly. You don't need to learn values of 2.6 and 3, but you do need to recognize the oceanic, although thinner, is denser, and although is thicker, has a lower density reading here. And you might learn just like basalt granite as your key differences there. Remember, you're not going to have to go into this in masses of detail. Now, this is a little bit more precise science here. You can learn this as the MOHO discontinuity. I wouldn't worry about that. This is the scientist that kind of discovered it, and it's simply the divide line between the crust and the upper part of the mantle. That's all it is. I would be stunned if you got asked a question on that. But I don't want to just teach the spec, right? But I am flagging it up. So, you know, that red line there, that's the MOHO. That's the divide line between when you go from rust to upper part of the mantle. So you can see that's the division within the lithosphere, right? Learn it, not learn it, that's down to you. Moving into a few more of the slides here. So again, just a few things here about the mantle. Key thing, it's molten. There's our depth readings. Now, I put, that's not 3 degrees. Personally, I would say, and this is the danger of using different textbooks, I would say 1500 to up to 4000, 3000, as long as you're in that ballpark figure. No, it says something different there. And that should say degrees C. That figure would be lower, closer to the outer core. And 1500 would be just below the crust. Remember, all easily enough to kill you. And then we start to bring in this idea of convection currents, which will be mentioned earlier on. Certainly at Key Stage 3, you learn about the turning of the molten rock, driving the plates apart. And that theory still exists. It's still good, but there's additional theories that you learn about. A stellosphere, so this exists below the lithosphere, so an extra 200 kilometers, and this is where the rock is capable of flowing. Remember, it's not liquid, it does move. And purely for one of interest, mesosphere does exist below it, but they think it's much more rigid. It extends quite a distance below it. Never seen a question that asked that. And probably because mesosphere is also used in the atmosphere. It's one of the upper atmosphere layers, so it's got like a double word there. So again, just teaching slightly beyond the spec. So definitely know that. That you can discard really, I suppose. And just to clarify a little bit about magma. Now, actually, these 2 pictures, technically speaking, are on the surface. So their name really changes to lava. It's difficult to find a video clip that kind of shows that in a way that actually means something to you. So again, I'll just talk about this to clarify this because it gets referenced a few times. Not all magma is the same. The generation of magma can be different. So like you can get magma that comes directly from the mantle. That's hotter, usually about 1300 degrees. And when you look at the components of it, it can have more or less silica. Silica is what you use in glass. So the more silica in it, the more sticky it is, the slower moving it is. If the temperature is hotter, it's going to be more fluid. And remember, it's not a fluid, but it will move more that way and therefore move quicker. And you also look at things like the amount of gases it has in it. So the combination of the various different elements lead to the rate of movement, the landforms that can create from it, and some of the nature of the eruptions that take place from it. So they said, like, not all magma comes from the mantle. Some of it comes from the melting of plates. More on that later on. So again, you don't want to get too consumed with all the distances and things like that. But I mean, the key things to take away from this: inner core, massive engine of the Earth, right? So you've got like just general heat decay, but also you've got nuclear decay as well. So you've got like this breakdown of isotopes giving off tremendous heats. And maybe 5,000–6,000 degrees, you know, within that core. And that's similar temperatures to the surface of the Earth, not Earth, to the sun, which I mentioned in the beginning of the slideshow. But just, you know, you might remember some of these things. I think learning all these distances here, they're there on the slide, but don't get too consumed with that. Okay? More about the fundamentals. So checkpoint, what I've got for you here is a quiz. Now, most of the quiz is based on the slide points, but I've put some almost like throw forward type sort of questions for you to think about. Okay, so what you do with this checkpoint in this slideshow, you maybe just write down 1 to 10 and put down your answers, pause the video, and then you'll see the answers. So here we go. Now, keep this first one basic, right? Almost like Key Stage 3, Key Stage 4, rather than think of all those sub-layers that I mentioned, because I've written the quiz based on that rather than the extra layers that I'm talking about. That's fine. That's fine. I think, to be honest, the rest of the questions up to this one, I've definitely gone through the slides on here. 9 and 10, I'm just interested to see whether you have an answer for that. So anyway, put one-word answers down, pause the video, and then we'll restart and I'll show you the answers. No cheating though. Welcome back. Here are the answers. Have a little look through them. Again, you can pause that. These questions I'll explain more in the next lesson. Now on this one here, again, just a little bit of a recap here, but showing a bigger picture, and you can see some of the landforms coming in here. There's the lithosphere, crust, and the part of the mantle. The asthenosphere, maybe another 200 kilometers beneath it, which is more molten flows in nature. But again, you can start now just kind of like linking some of these landforms. When I say landforms, the crust, what I mean by that structure. And you can see, oh look, volcanoes, island arcs, trenches. It's raised, therefore maybe a mountain, that side of it, and just kind of like stimulating your interest, and going from there. This one here again is all right. Okay, so what I would do here is go right. There are 5 bullet points, and you might call it a blurt or maybe a messy mind map, whatever you want to do, and just go right. I'm going to pause this, and I'm just going to try to repeat as much information, rat-a-tat-tat, for those 5 headings, what I can remember. Okay, remember retrieval is a really important thing to do. So use the previous slides and what you know, and just try to like rapid fire do something, as in see what you can extract from your memory, and then check. And the last part here, what I've got for you here is a couple of videos where they give some extension work, some repeating some of the things that I've said, and there'll be some additional stuff here just to pique your interest. Because it's all about doing extended work here. And that basically is the Earth structure. Next lesson, I'll be talking to you about plate tectonics, theory of it, the rudiments of it. I'll be talking about plates themselves, which links into do with the Earth's crust. I'll be talking about plate boundaries and the mechanisms they move. You know that. Many of you know that they move. So I'll be going through 3 theories: convection cell theory, I'll be talking about ridge push theory or gravitational sliding, and I'll talk about slab pull theory. But anyway, that's the end of this video. Obviously, there'll be some associated tasks with this, and I will see you next lesson. Thank you for putting up with me. Bye.